Simplifying a complex fraction. It's the fourth of 6 algebraic manipulations you can use when evaluating limits algebraically. Now, the strategy for evaluating limits in this algebraic way will be to first try direct substitution, and if that fails, which it very often does, we want to think of simplifying a complex fraction as one of the tools that can help us proceed in finding the limit. Let me show you an example of how it works. Take a look at this limit here. The limiting value is -2 this time, and I'm going to go through the motions of trying direct substitution. I always want to try taking this limiting value and plugging it in for every x that I see on the inside of the limit. So I'll get 4 plus 1 over -2 plus 2 all over 1 over -2 plus 2 minus 3, which when you start simplifying, and down here too. You have a 0 in the denominator of this little fraction up here, and you have a 0 in the denominator of this little fraction down here. And so you have basically a double dose of trouble here, and you know that direct substitution is not going to work because you're getting that 0, actually 2 of them, in 2 different denominators. So, and that's really happening because of this factor of x plus 2 that's in the top and this factor of x plus 2 that's in the bottom. See, because the limiting value is -2, and when I try to plug that into x plus 2, of course I'm going to get 0. So maybe there's some way that I can manipulate algebraically what's going on the inside of the limit to get rid of that x plus 2 factor. And that's precisely what we're going to do. What's going on inside the limit? I mean, when I say this is the limit as x goes to -2, so I'm just going to rewrite the limit real quick. What's going on inside the limit is what's called a complex fraction. A complex fraction is a fraction that has fractions inside of it. So you can see here that there's a fraction 1 over x plus 2 in the top, and there's a fraction 1 over x plus 2 in the bottom. So there's fractions inside a much larger fraction, and that's what in mathematics we call a complex fraction. So what we want to do is try to simplify this complex fraction, and hopefully when we simplify this complex fraction, that factor of x plus 2 that's in the bottom of both of those mini fractions can somehow go away, and it will, and I'll show you how it works. So what you want to think about when simplifying a complex fraction is you want to try to get the giant numerator to be one fraction. So this guy up here, we need that to be one fraction, and the denominator down here needs to be one fraction. See, right now it's like 4 plus a fraction and a fraction minus 3. So what we need to do is create common denominators. That'll be the first step. So I'm going to create common denominators in the top and the bottom. So for example, this 4 can be written as 4 over 1, and I could certainly multiply the top and the bottom by x plus 2. And when I do that, what I'll be setting up is a common denominator with this other piece of this big numerator. And similarly down below, I can write this 1 over x plus 2 will just stay the same, but this 3 I can write as 3 over 1 and then multiply it by what I need to get the common denominator. Essentially, when you multiply by, let's say, x plus 2 over x plus 2, you're not changing the value of anything, you're just changing the way that it looks. You're just multiplying by 1, which is okay. So now we've sort of set up a situation where we're going to create common denominators, and now I just need to sort of clean up what I did so I can see what's happening here. All right, so what do I have? Well, this 4, so you got to be careful because this 4 is going to distribute. When I multiply it, I'm going to distribute it to both the x and the 2. So I'm going to end up with 4x plus 8 all over x plus 2. And then you still have this plus 1 over x plus 2. And that's the big numerator. Notice how we have that common denominator now of x plus 2 and x plus 2 over here. That's what we wanted. That was the whole point. And then down here we have 1 over x plus 2. And then again, this 3 is going to distribute to both the x and the 2. So we'll get minus 3x plus 6 all over x plus 2. All right, great. Now we can take the step of actually combining the fractions that are in the numerator and combining the fractions that are in the denominator. Carrying through the limit, of course, in every step because I'm not applying the limit yet. I'm going to keep that limit symbol in the front of this expression until I plug in the limiting value later on. So it's really important that you keep that limit symbol in the front. Okay, so now to combine the fractions, I'm going to combine the numerators, and that looks like I'll have 4x plus 8 plus 1 all over x plus 2, and then a big fraction bar, and then on the bottom, just really got to be careful here. I'm going to make sure this minus distributes to both pieces. Okay, so on this numerator, I get 1 minus 3x minus 6 all over x plus 2. So like I was saying, the whole goal is that you sort of start with this situation up here where you have multiple terms in the numerator and multiple terms in the denominator. And the first step of simplifying a complex fraction is to create a single fraction in the numerator and a single fraction in the denominator. And that's precisely what we're doing. You can see that that's already getting set up here. Notice that we have a single fraction in the numerator and a single fraction in the denominator. We can just clean up a bit more, and then I'll show you where to proceed, how to basically divide that big fraction by another fraction. So we have on the numerator on the top 4x plus 9 over x plus 2. And then the bottom cleans up to, let me write it as minus 3x, and then 1 minus 6 would be minus 5 all over x plus 2. Great. Okay, so now I have a fraction divided by a fraction. And the way that we handle fraction divided by a fraction is to take the fraction that's on the bottom and flip it over. So turn it upside down and then multiply it to the fraction that's in the numerator. So I'm going to go ahead and do that in the next step here. I'm going to take that bottom fraction, which is the minus 3x minus 5. I am going to take that bottom fraction and I'm going to flip it over, which will be x plus 2. So right, if I think about flipping this over and then bringing it up and multiplying it to the top, right? So that I flip it over, so it'll be x plus 2 over minus 3x minus 5. And then I'm going to multiply them. I'm going to multiply those two fractions together. And when I do that, notice the big cancellation that will happen between the x plus 2 in the top and the bottom here. They will go away. And if you remember from the very beginning of the problem, those were the factors that were causing the zeros in the denominator to begin with. This 0 here and this 0 here were being caused by this factor of x plus 2 and this factor of x plus 2. So now at the very end of this procedure of simplifying this complex fraction, that factor of x plus 2 has canceled. And that's what's really going to fix the problem of the 0 appearing in those denominators in the beginning, which is great. It's exactly what we want. Okay, so just another cleanup step here. This is the limit as x approaches minus 2. And now what's on the top? Let's see, 4x plus 9. And the denominator now only has minus 3x minus 5. Awesome. Okay, So now that special factor has been taken care of, that x plus 2 is canceled, now I want to return to trying to plug in the limiting value. And you'll see that now we're not going to have any issues this time. Let me go ahead and buy myself a bit more room here. So now I'm going to go in and plug in this negative 2. So I'm going to get 4 times minus 2 plus 9 all over minus 3 times minus 2 minus 5. Notice how I dropped the limit symbol. I'm no longer writing this limit as x approaches negative 2, and that's because I've plugged in. I did the same thing at the top whenever you try direct substitution. When you're plugging in the limiting value, that's when you drop the limit symbol. When you're doing all of the algebraic manipulation, just changing the way the inside of the limit looks, you don't fool around with the limit on the outside. You sort of let it carry through in each step, and that's really important as far as your notation is concerned. Okay, so there's really only 1 or 2 more steps here of just simplifying this. This is just arithmetic from here. So what do I get? Minus 8 plus 9 over 6 minus 5, which reduces to 1 over 1, which is conveniently 1. So the limit in this case is 1. If direct substitution fails and you see a complex fraction on the inside of the limit, try simplifying it. The algebra can be a bit tricky, but just remember to make common denominators when adding or subtracting fractions. And don't forget, when you divide by a fraction, it's the same thing as multiplying it by its reciprocal. So we now have 4 tools to consider when direct substitution fails: factor and simplify, expand and simplify, combining fractions, and now simplifying a complex fraction. The next twist, multiply by the conjugate, is the 5th algebraic manipulation to consider when evaluating a limit algebraically. Check it out in the next video if you want to see more about multiplying by the conjugate.